Everyone and welcome back to Schoolosophy. So last week I couldn't post a video because I had my exams going on and I'm really sorry. Today I'm going to introduce quantitative chemistry, which is also known as stoichiometry. So let's start. We need to be able to predict the amount of matter of a substance that we use in a chemical reaction. To do this, we take the mass of a substance. So here we use the relative atomic mass, that is AR of a substance. The relative atomic mass of an element is the average of all the naturally occurring atoms of the element. Now in one of my previous videos I spoke about isotopes. Isotopes are atoms of the same element which have the same number of protons and electrons but different number of neutrons. So the relative atomic mass, that is AR, is the average mass of all the isotopes of a substance. Let's take this example of carbon. The relative atomic mass of carbon is exactly 12. So we use this carbon as standard mass to calculate or predict the average mass of other elements. Like for example, one carbon atom is equal to 12 hydrogen atoms. That is, the mass of one carbon atom is equal to 12 hydrogen atoms. So we can predict that with the relative atomic mass of carbon being 12, the relative atomic mass of hydrogen will be 12 divided by 12, that will be 1. Next, we have the relative formula mass or MR of a substance. The relative formula mass of a substance is the total of the relative atomic masses of all the elements present in a formula unit. So many atoms occur naturally as molecules. For example, hydrogen, nitrogen and oxygen. This means that they occur as two atoms together. So the relative formula mass for an H2 molecule will be equal to its relative atomic masses sum. That is, it will be equal to 1 plus 1, which is 2. So the relative formula mass for an H2 molecule will be equal to 2. Let's take this example of water. The chemical name of water is H2O. So the relative formula mass of water will be equal to 16 plus 1 plus 16, which is equal to 33. That is the relative atomic mass of two oxygen atoms and one hydrogen atom. Finally, let's take this example of sodium chloride. This is a chemical name for table salt. So the relative formula mass for sodium chloride will be 23 plus 35.5, which is equal to 58.5. This relative formula mass is also known as relative molecular mass for substances that occur naturally as molecules, that is, for substances like hydrogen, oxygen or nitrogen which occur as molecules, maybe H2, maybe O2, N2. This is also known as relative molecular mass. It is certainly not possible to measure the mass of atoms and molecules when performing a chemical reaction. Atoms and molecules are too small. That is why we need to develop a counting unit, which is the moles. The amount of matter in a substance is also called as moles. You can also write moles as MOL. So the moles is equal to the relative formula mass or the MR in grams. We find the amount of atoms or molecules in a substance by using the Avogadro constant. So the number of moles we have, we multiply that by 6.02 into 10 raised to 23 to find the amount of atoms, molecules or any formula units present in the substance. We can find moles by using this table here, this triangle here, which has mass in grams on the top and number of moles and molecular mass on the bottom. Whatever you need to find out, just cover that part. So for example, if I need to find out the number of moles, it is the mass in grams divided by the molecular mass or the relative formula mass, the MR of a substance. If I want to find out the mass in grams, I will multiply the number of moles into the molecular mass. And if I want to find out the molecular mass, I will divide the number of moles and the mass in grams, that is mass in grams upon the number of moles. Let's see how to find the number of moles of a gas. A volume of any gas will have the same number of particles. This is known as Avogadro's law. From this law, we develop a theory that any gas will have a volume of 24 dm cube. That is 24 volume or 24 liters at room temperature pressure. which means that the molar volume of any gas will be equal to 24 dm cube per mole at room temperature pressure. So to find the number of moles in a gas, we do volume divided by the molar volume. The molar volume will remain constant, which is 24 dm cube per mole, and to find the number of volume, the volume of a gas, we do number of moles multiplied by the molar volume. Let's see how to calculate moles in reactions. So the question is, what mass of aluminium oxide is produced when 9.2 grams of aluminium reacts completely with oxygen gas? So to solve such questions, we first need to write a balanced chemical equation, which means we need to list down how the reaction will take place. That is, aluminium plus oxygen is equal to Al2 plus O3. And to balance this means that the number of atoms on either side should be the same. So we balance this by this way. The equation is balanced, so the number of atoms of a particular element are equal on both the sides. Second, we need to convert these 9.2 grams of aluminium to moles. So to convert into moles, we divide the mass in grams upon the molecular mass. So the molecular mass of aluminium is 27 and we get 0.34 moles. Here they have asked us to find out the mass of aluminium oxide. So before finding out the mass, we find out the moles of aluminium oxide. One very important thing is the ratio always remains the same on either side of the equation. And the ratio is taken by the number that we balance. So the ratio in this equation will be 4:2. We have the number of moles of aluminium and we need to find the number of moles of aluminium oxide. So we take the ratio 4:2. If the ratio is 4:2, which means 2:1, then if 0.34 grams of aluminium is produced, 0.34 moles of aluminium is produced, this means that 0.14 moles of aluminium oxide are produced. 0.17 moles of aluminium oxide are produced. To find the mass in grams of aluminium oxide, we multiply the number of moles by the molecular mass of aluminium oxide, which is 0.17 moles into 102, which is the molecular mass, which is equal to 17.34 grams of aluminium oxide produced. So this is how we use the moles and we compare it with the chemical reactions. Reactions involving gases. If 8 grams of sulfur are burnt with oxygen, what volume of sulfur dioxide is produced? The first step remains the same. We write a balanced chemical equation. Sulfur reacts with O2, that is oxygen, to give out SO2, that is sulfur dioxide. This is already balanced. So we need to remember that the ratio will always be 1:1. The ratio will always be 1:1. First we need to convert this 8 grams of sulfur to the number of moles. So number of moles is equal to mass in grams upon molecular mass. So 0.25 moles of sulfur reacts. Because the ratio is same, that is 1:1, the number of moles of sulfur dioxide will also be 0.25 moles. Now because sulfur dioxide is a gas, to find out the volume of the sulfur dioxide gas produced, we multiply the number of moles by the molar volume, that is 24 dm cube. So the volume produced will be equal to 0.25 into 24 dm cube per mole to 6 dm cube of SO2 produced. That is 6 dm cube of volume of SO2 was produced. Here are some practice questions that will help you practice quantitative chemistry. I will post the answers of these questions in the comments below, and I will also see the answers in my next video that I post. So just I'll read the questions for you. Calculate the number of moles in 112 grams of iron, 96 dm cube of oxygen. B. the volume of 3 moles of H2 and 8 moles of CO2. Second question, 0.07 moles of silicon reacts with bromine. Calculate the mass the silver bromide produced. Third, 6.9 grams of sodium reacts with water. Calculate the volume of hydrogen gas produced. If you have any doubts relating to these questions, if you want the balanced chemical equations of these questions, please put it down in the comments, and please do try these questions. That's it for this video. I hope you understood. If you have any doubts, please put it down in the comments. And if you want me to post a video on any topic, please put it down in the comments. And yes, please do practice those questions and post your answers in the comments below. I will also post the answers in the comments, and I will also tell the answers in my next video. So bye.